Welcome, everyone. I'm excited to kick off our session today with an overview of Module 1, titled Introduction and Bus Body Terminology. This is part of our AUT428 Vehicle Body Engineering and Safety course. Over the next few slides, we'll explore the fundamental concepts and key terminology related to bus bodies. We'll cover the basics to help you build a solid foundation for understanding vehicle body engineering. Let's get started. Today, we're going to explore the fascinating world of vehicle body engineering, focusing on three key aspects: classification, styling, and structural layouts. These elements are fundamental because they influence not only the vehicle's appearance, but also its safety, performance, and overall functionality. When we talk about classification, we're essentially looking at how different vehicle types are categorized based on their body styles and design principles. Styling, on the other hand, is about the visual appeal, how the vehicle looks and how that look aligns with brand identity and consumer preferences. Lastly, structural layouts refer to the way the vehicle's body components are arranged to provide strength, rigidity, and safety. Understanding these aspects helps us appreciate the complex engineering decisions that go into designing a vehicle that's not only attractive, but also safe and efficient. As we move forward, keep in mind how these elements work together to shape the vehicles we see on the road every day. Let's take a closer look at the classification of coach work types. First, we have the semi-integral approach. This is essentially a hybrid method where subframes are attached to a partially integrated body structure. It strikes a balance between reducing weight and maintaining load-bearing capabilities. It's quite versatile and often used where efficiency is key. Next, we have the conventional body, also known as body-on-frame. In this setup, the body is a separate unit mounted onto a rigid chassis frame. This design is preferred for heavy commercial vehicles, off-roaders, and large buses, primarily because of its superior load capacity and durability. Finally, there's the integral body, or monocoque construction. Here, the chassis and body are integrated into a single, unified structure. This design offers high rigidity and is much lighter, which is why it's predominantly used in modern passenger cars. It improves performance and safety while reducing weight. Connecting this to the overall theme, understanding these different types helps us see how vehicle design balances factors like weight, strength, and application needs. Each type has its own advantages depending on what the vehicle is meant to do. Let's take a closer look at vehicle styling forms. When we talk about the exterior, the visual appeal is really about creating a look that catches the eye. This involves modern styling lines that give the vehicle a dynamic feel, balanced proportions that make it look stable and well-designed, and specific brand identity features that help the vehicle stand out and attract consumers. It's about making sure the exterior not only looks good, but also communicates the brand's personality. Moving inside, the focus shifts to aesthetics. Designing the interior layout isn't just about how it looks, it's about how it feels and functions. We aim to maximize human-machine interaction, meaning the controls should be intuitive and accessible. Passenger comfort is key, so seating and space matter a lot. Driver visibility is crucial for safety, and easy ingress and egress ensure convenience. All these elements work together to make the interior inviting and user-friendly. Finally, let's talk about aerodynamics. Developing streamlined shapes is essential for reducing the air drag coefficient. When a vehicle is more aerodynamic, it improves fuel efficiency, which is a big plus for both cost savings and environmental impact. It also helps minimize wind noise, making the ride quieter, and maintains high-speed stability, which is vital for safety and performance. These design elements are all interconnected, supporting the overall goal of creating vehicles that are not only attractive, but also efficient and safe to drive. Let's take a closer look at the differences between coach and bus body styles. Starting with the luxury coach, these are engineered primarily for long-distance intercity or tourist travel. The main focus here is passenger comfort. You'll notice they feature high-deck floors, which are designed to allow for large underfloor luggage compartments, making it easier to carry lots of baggage. Inside, you'll find plush reclining seats that enhance comfort during long trips, along with advanced climate control systems to keep passengers comfortable regardless of the weather outside. Additionally, they have superior acoustic insulation, which helps reduce noise and creates a more peaceful travel environment. On the other hand, city or transit buses are designed for urban environments with frequent stops. They're built for quick, efficient boarding and alighting, which is why they have low-floor layouts. These make it easy for passengers, including those with mobility challenges, to get on and off quickly. You'll also notice the extremely wide pneumatic doors that facilitate fast boarding and a maximized standing room area to accommodate more passengers during busy times. However, these buses tend to have minimal luggage space, since their primary purpose is short-distance travel within cities. The seating arrangements are highly durable and utilitarian, designed to withstand heavy daily use. So, in essence, these two styles serve different transportation needs. Luxury coaches prioritize comfort and space for longer journeys, while city buses focus on efficiency and quick passenger turnover in urban settings. Let's take a closer look at the vehicle layout and capacity matrix. Here, we see different types of vehicles categorized by their seating capacity, primary application, and structural layout. Starting with the passenger car, which typically seats between 4 and 7 people. These are mainly used for personal transport or carrying light luggage, making them ideal for everyday use. Structurally, they usually feature an integral, or monocoque, design with the engine placed at the front or midsection. Next, we have the minibus, which can carry between 12 and 25 passengers. These are commonly employed for short-haul commutes or shuttle services. Their structural layout is body-on-frame, with the engine located at the front, providing robustness and flexibility. Moving on to city buses, which are designed for high-volume urban transit. They typically seat 30 to 50 passengers, plus standees during peak hours. Their semi-integral design often features a rear engine and a low-floor layout, making boarding and alighting easier for passengers. Finally, the luxury coach, with seating capacities ranging from 40 to 55. These are used for intercity travel or long-distance journeys, often accommodating heavy luggage. Structurally, they are integral vehicles with a rear engine and a high deck, focusing on passenger comfort and capacity. Overall, this matrix highlights how vehicle design is closely aligned with its intended application and passenger capacity, emphasizing the importance of choosing the right layout for specific transportation needs. Let's take a closer look at the different types of commercial vehicles. First, we have heavy trucks. These vehicles are built with extremely rigid, high-tensile steel frames, which are essential for supporting very large payloads. They include rigid trucks and articulated tractor-trailers, and their design is all about durability and strength to handle heavy loads efficiently. Next up are pickups. These are quite versatile because they feature an open cargo bed along with a separate passenger cabin. This makes them perfect for a variety of tasks, whether it's construction, agriculture, or utility work. Their flexibility is a big advantage in many different industries. Finally, we have vans. Vans are fully enclosed, with cargo spaces integrated directly into the driving cabin. This design makes them ideal for urban delivery and last-mile logistics, where security and protection from the elements are important. Connecting this to our overall theme, understanding these different vehicle types helps us optimize logistics and transportation strategies across various industries. Each one has unique features that make it suited to specific roles, which is crucial for efficiency and safety in commercial operations. Let's take a closer look at some of the key terms used in bus bodybuilding, specifically focusing on structural elements, geometry, and framing terminology. These concepts are essential because they form the foundation of how a bus is designed and constructed. When we talk about structural elements, we're referring to the main parts that give the bus strength and stability, like the frame and support beams. Geometry, on the other hand, deals with the shape and layout of these components, ensuring everything fits together perfectly and functions as intended. Framing terminology covers the specific parts and their functions within the structure, helping us communicate clearly about what needs to be built or repaired. Understanding these terms not only helps us in the design process, but also improves our ability to troubleshoot and maintain the bus over its lifespan. Throughout our discussion, keep in mind how these elements work together to create a safe, durable, and efficient vehicle. Let's take a closer look at some crucial vehicle geometry aspects that really impact a vehicle's performance and usability. First up is ground clearance. This is essentially the minimum vertical distance between the lowest stationary part of the vehicle, like the chassis or body, and the ground. Think of it as the clearance that determines whether your vehicle can handle rough terrain without getting stuck or damaged. Next, we have the angle of departure. This is the steepest ramp or slope from which the vehicle can safely descend without the rear overhang or bumper touching the ground. It's really important for off-road driving or situations where you need to go down a hill with a sharp edge. Then there's the angle of approach. This is the maximum steepness of a ramp or incline onto which the vehicle can climb from a flat surface without the front bumper or undercarriage hitting anything. This measurement helps us understand how well a vehicle can handle steep inclines without risking damage. All of these factors, ground clearance, angle of departure, and angle of approach, are interconnected and play a vital role in vehicle design, especially when considering terrain versatility and safety. They tie back into our overall theme of designing vehicles that are not only efficient, but also capable of handling diverse driving conditions. Let's take a closer look at the key components of the floor structure. First, we have the heavy transverse structural members. These are the large, horizontal beams that stretch across the width of the vehicle. They're securely attached to both the chassis and the floor longitudes, providing essential lateral stiffness. This means they help prevent the floor from twisting or bending under load, which is crucial for maintaining the overall integrity of the bus. Plus, they support the significant weight of the side panels, seats, and passengers, ensuring everything stays safely in place. Next, we have the cross bearers. These are the longitudinal structural members that run parallel to the main chassis frame. Think of them as the backbone that runs along the length of the bus. They form the primary foundation of the floor, helping to distribute the passenger and cargo loads evenly across the entire structure. This even distribution is vital for durability and safety, as it prevents stress concentrations that could lead to damage over time. Finally, we have the floor longitudes. These are the longitudinal beams that run along the length of the vehicle, connecting the cross members and cross bearers. They play a key role in forming the overall framework of the floor, providing longitudinal strength and stability. Together, these components create a robust and reliable foundation for the bus, supporting everything from the chassis to the interior fixtures. By understanding these elements, we see how each part contributes to a strong, safe, and durable vehicle structure, which is fundamental for both performance and passenger safety. Now, let's take a closer look at the side framing elements of the bus. First, we have the side framing members, which are internal longitudinal structural components running along the side wall framework. These are crucial because they provide a secure anchor point for the passenger seats, ensuring they meet crash test standards and keep passengers safe in the event of an accident. Next, there's the seat rail. This is a continuous, long horizontal member that runs just below the window line along the side of the bus. Its main purpose is to add critical rigidity to the midsection of the vehicle, helping to maintain structural integrity and passenger safety. Then we have the waist rail. These are the main vertical structural members forming the side framework. They must withstand significant vertical loads from the roof, as well as side impact forces during a collision. Their strength and stability are vital for the overall safety and durability of the bus. Finally, there are the posts, or pillars. These vertical supports help connect different structural elements and contribute to the overall robustness of the side framing system. All these components work together to ensure the bus's structural integrity, safety, and compliance with crash standards. They are essential parts of what keeps passengers protected and the vehicle durable in various conditions. Let's take a closer look at the upper framing structure. First, we have the roof longitudinal members. These run along the length of the roof and are crucial for maintaining stability. They intersect with the roof sticks, which helps prevent the roof panels from sagging and also provides rollover stiffness along the length of the roof. Next, we have the roof sticks, also known as roof bows. These are transverse curved members that span across the entire width of the roof. Their main role is to connect the cant rails on either side and help maintain the roof's geometric shape, ensuring it stays properly contoured. Finally, the cant rail is a key longitudinal structural component. It connects the top of the vertical side posts to the roof structure, effectively serving as the upper boundary of the side framing. Together, these elements form a strong, interconnected framework that supports the roof and maintains its shape, which is essential for overall structural integrity. Let's take a closer look at the outer panels and reinforcements that are essential to the bus's structural integrity. First up are the post diagonals. These are diagonal bracing members that are strategically placed between the vertical posts. Their main role is to prevent the side frames from racking or distorting, especially under extreme forces like heavy braking or rapid acceleration. They really help maintain the shape and stability of the bus. Next, we have the truss panel. This is a specialized structural panel located beneath the windows or inside the side structure. Its purpose is to absorb and distribute shear loads, which helps prevent the rectangular frame from twisting. This is crucial for maintaining the overall rigidity and durability of the bus. Now, moving to the skirt rail. This is the lowermost horizontal member along the side of the bus, forming the bottom edge of the body. The skirt rail provides additional rigidity to the lower panels and also defines the ground clearance boundary, ensuring the bus sits properly on the road. Finally, let's talk about the rub rail. This is an exterior horizontal molding or protective strip along the sides of the bus. Its primary function is to protect the outer side panels from minor scrapes, side swipes, and impacts, particularly in busy traffic environments. It acts as a first line of defense against everyday bumps and knocks. Together, these components are vital for ensuring the bus remains strong, stable, and well protected throughout its service life, fitting into the overall theme of building a safe and reliable vehicle. Let's take a closer look at the wheel arch and corner joints. These areas are crucial for the overall strength and durability of the structure. We often use triangular or specially shaped heavy-duty metal plates, which can be welded or riveted at the intersections of key structural members, such as where a post meets a cross bearer. These gussets play a vital role because they help significantly reduce stress concentrations that can occur at these joints. By doing so, they strengthen the corners against bending moments, which are forces that could otherwise cause deformation or failure. Now, moving on to the gussets themselves. These are the semicircular structural housings located above the wheels. They are heavily reinforced because they interrupt the continuous lower side framing, which is a critical load-bearing element. The gussets must also accommodate full suspension travel, meaning they need to be strong enough to handle movement and shocks without compromising the structure. Additionally, they serve an important function in preventing water and debris from entering the body, which helps in maintaining the integrity of the vehicle over time. Overall, these components, corner joints with gussets and the wheel arch structure, are essential for creating a robust, reliable, and weather-resistant frame. They ensure the vehicle can handle stresses, shocks, and environmental challenges effectively. Now, let's talk about why these elements really matter. The precise engineering of cant rails, posts, roof sticks, and gussets is crucial because it ensures that the bus body meets strict international safety standards. These components work together to form the structural skeleton of the bus. In the unfortunate event of a rollover crash, this skeleton must do its job effectively. It needs to prevent a catastrophic collapse, which is essential to protect the internal, survival space where passengers are seated. This is where the rollover structural strength comes into play, guided by standards like the R66 standard and regulations such as ECE. These standards emphasize that the bus must withstand severe impacts without compromising the safety of everyone inside. So, every detail, from these structural elements to the overall compliance with these standards, contributes to making buses safer and more reliable. It's all about safeguarding lives by ensuring the bus's integrity, even in extreme situations. And that wraps up our overview of Module 1, Introduction to Vehicle Body Engineering. Now, before we move on, I'd like to open the floor for any questions you might have. This is a great opportunity to clarify any points or dive deeper into topics you found particularly interesting. Remember, understanding these foundational concepts is crucial as we progress through the course. So feel free to ask anything. No question is too small or too complex. I'm here to help ensure everyone is on the same page before we advance. Thanks for your attention so far, and I look forward to our next module together. Now, let's take a look at the sources for the images we've referenced throughout this presentation. You'll notice the first one is from IndiaMart.com, which provides a good visual of bus body structures. The second image, from DriverKnowledgeists.com, illustrates important concepts like ramp approach and departure angles, which are crucial for understanding vehicle clearance and safety. Moving on, we have an image from FogLabel.com showing a commercial vehicle, highlighting the design and build aspects we discussed earlier. Next, from Ford.com, there's a picture of a Ford Super Duty truck, giving us insight into heavy-duty vehicle characteristics and design features. The fifth source is from ISTICPhoto.com, displaying a modern cargo van, perfect for understanding different vehicle types and their uses. Finally, from EngineeringCheatSheet.com, we see a technical diagram that helps us visualize key measurements like wheelbase and angles. These sources collectively support our discussion on vehicle design, safety, and functionality, connecting back to the overall theme of understanding vehicle engineering and its impact on performance and safety. Let's take a moment to acknowledge the sources of the images we've used throughout this presentation. The primary source is Tesla's official service website, ServiceTesla.com. Specifically, the diagram we referenced is from their detailed Model Y service manual, which you can find online at this link, https://service.tesla.com/docs/Model Y/service manual/NA/GIDI 16CB08070-7A4641-011999E17527 online NUS. APG. It's important to recognize that these images and diagrams are provided by Tesla to help technicians and owners understand vehicle components better. They serve as a valuable resource for maintenance and repair, emphasizing Tesla's commitment to transparency and support. By understanding where our information and visuals come from, we reinforce the importance of using reliable, manufacturer-approved sources when working on or learning about electric vehicles. This connection to official documentation underscores the overall theme of the presentation, the importance of precise knowledge and proper resources in maintaining Tesla's innovative technology.